In this video series, we've been looking at analyzing categorical data, and specifically, we're looking at analyzing categorical data that has been obtained using a model of homogeneity. That is, we sample from multiple groups. I'm now going to take the analysis that I've been doing relating teacher training to teacher response to classroom misbehavior and put that in the form of a report. So the research question here is there a relationship of teacher training to the way those teachers respond to classroom misbehavior? Here's a description of my report. Teacher training addresses many aspects of the classroom, including behavioral management. Nonetheless, there are multiple paths to becoming a teacher, some of which do not include traditional types of training. This prompted one education researcher to study the relationship of the level of teacher training, and then I give those levels which define the categorical variable: no formal training, some training, and much training. So those are the three populations that I'm interested in, and we're going to obtain a sample from each of those populations. And I'm looking at the relationship of those levels of teacher training to the response to misbehaviors in the classroom. The researcher recognized that alternative certification programs with little or no formal training might lead to different responses to misbehaviors. So to conduct the study, the researcher randomly selected 60 teachers from each of the three populations. Note, three populations, not a single population in which we measure on multiple variables, but three specific populations we've identified and we have sampled from. That's what makes this the model of homogeneity. Raters were trained to classify responses to misbehaviors in one of three ways. So now we're indicating the response variable and that it is also categorical with the following levels: punitive, reasoned, or evasive. Those are the three categories for the response variable. These raters then observed the 180 teachers in the classroom and selected the primary type of response for each teacher. So we have 60 teachers from each of three populations, and 3 times 60 is 180, and the teachers are observed in actual practice. So now I begin my analysis, and I begin with a bar graph. You may recall that when we were looking at this earlier in another video, that we calculated descriptive statistics first because they're necessary for the bar graph, but in the report I always prefer to start with a visual display. So if you look at my code for this, you'll see that I actually am calculating the proportions right here on line 38, but I'm not showing them at this time. I'm just using them in order to create my bar graph. So here's the bar graph. The bar graph in figure 1 illustrates the proportion of teachers that respond in one of the three ways for each of the three samples in the study. Several patterns are clear, and that's why I'm actually showing the graph first, is so we can look at the general patterns overall. First, less training is associated with more punitive responses. Notice that punitive here is in black, as shown in this legend, and I see, it catches my eye right away, that there's a lot of black in the first bar, not so much in the second and third bars. In contrast, more training is associated with more reasoned responses. I notice the pink, the reasoned responses, gets bigger as we go from left to right in these bars. Now this is an ordinal categorical variable because we're talking about none, some, or much, but we're treating it in the same way that we would treat a unordered or nominal categorical variable. Many teachers with some training were also reasoned in their responses, though about a third of these teachers were evasive, as I see in the bar here. And I'm just roughly estimating that looks like about a third that is green here in this second bar for the evasive category. So now if we want to drill down further, I provide Table 1. Table 1 contains the proportion response by training condition of the teachers with no training. Almost half were punitive in response to their teacher training. So if I look at no training, I see here that it's 45%. So I'm just stating it that it's about half. And notice that these are conditioned on columns, that if you add up these proportions in every column, they will add up to 1. They'll add up to 1 for the none, add up to 1 for the some, add up to 1 for the much. So we are conditioning on the columns, which are the levels of the explanatory variable. And that's what you want to do. You want to condition on the levels of the explanatory variable in order to compare the proportions. Of those with much training, about 2/3 were reasoned in their responses. You see that right here. And only 12% of these teachers were punitive in their response. You see that right here. Teachers with some training fell in between these two groups. About half of these teachers were reasoned. Right here, it's really 47%, so I'm just rounding or roughly saying about half. About 1/3 were evasive, and the remainder were punitive. Here's the evasive. Now I'm going to look at making inferences, and I say the conditions for inference are met in this study. The teachers in the study were observed independently of the other teachers, and each teacher was categorized in only one training and one response to misbehavior condition. Indeed, we pulled out teachers from the different training conditions. They're obviously going to be independent in the different conditions. And then by sampling independently from each of the three populations, then we ended up with independence both within and across conditions. Then I also say the expected values in every cell are greater than 5. There's no need really to show that as long as I've checked it. So if you look over here in my code, you will see down here that I actually calculated the expected, and I looked over here at the expected. I could actually type it in here, expected, and that gives me the expectations, and I notice that they're all above 5. So that's why I made this statement here about that we have expected values in every cell are greater than 5. The hypothesis of proportional equality across the three training conditions can be rejected, and I give the p-statistic here, less than 0.001. Where did that come from? Well, if you come down here, I actually used it for the same chi-square test. On line 62 is where I saved the data from the chi-square test. I used that same saved data and obtained the p-statistic here. And if you look over here in the environment window, here's my p-statistic of 0.000124, which is why I just expressed it as less than 0.001. If that p-statistic had been bigger, I would have said p equals 2, but I didn't want to put p equals 2 and give that number with all those zeros in front of it. So I just said p less than 0.01. Otherwise, I would have told the actual number that p was equal to. Thus, we can infer with 95% confidence that teacher training is associated with the response to misbehaviors in the population of teachers. So that's my omnibus test. Now note Table 2. I'm now going to do a post-hoc analysis. Table 2 provides the differences among the proportions for pairs of training conditions. In the sample, teachers with no training were substantially more prone to be punitive, about 30% percentage points higher than teachers with at least some training. Let's see if we can see that. So teachers with no training compared to teachers with no training more punitive than teachers with at least some training. So I'm comparing the none to some difference for punitive, and I see there it's 0.27, so it's 27%. We could say that, but I'm saying it in ways I can easily remember, about 30 percentage points higher than teachers with some training. Those with no training were more punitive. Teachers with much training were more reasoned by about 30 percentage points than those with no training. So now I'm comparing none to much. And if I compare none to much, here I see that it's negative because of the way that I subtracted. I took the none first and subtracted the much, which means that much is higher by 0.32 or about 32 percentage points. So I called it about 30 percentage points than those with no. And when I compared none to some, similarly with none to some, let's see, none to some, here it is, the difference. And for reasoned, it's, well, I'm not sure why I didn't just say about 15 percentage points, because at none to some, I said about 20. So it looks like I'm rounding to tens for each of these statements. But we can see that there is 0.15 or 15 percentage points than those with some training, in greater proportion than those with no or some, and with no training and with much training, so none compared to much, less evasive than those with some training by about 10 percentage points. So teachers with no training and with much training, we're both less evasive, got it. So none to some, there it is, and then some to, comparing none to much, and that's also here. There. Okay. All right. So where did this come from? This came from doing all these post hoc tests. So I used either some symbolism or spelled it out, like here, none to some punitive, and then I abbreviated it here for the standard error to NSP, so I could keep track of all these things later on. So here I'm calculating the contrast. Here's the critical value, and it's a Chaffee critical value, so I only need to calculate it one time. Then I have to calculate each contrast. You'll see the 60s because there's 60s that go into each proportion. You see the proportional estimate times 1 minus the proportional estimate for each group that I'm comparing. So I'm doing this for none some punitive, none much punitive, some much punitive, none some reasoned, and so forth. All the way through, I did all of these. And then I went ahead and created a, I actually don't need this. I started to do this and then decided to delete it. So I'm going to go ahead and take that out of there. And I think everything should still knit fine. Let me double check. Yeah. And so I went ahead and calculated all these, and then I set them up into a data frame. So once I ran this and set it up to a contrast data frame, so let me go ahead and run this, and I'll run everything above to make sure it runs. And so I ended up with this contrast data frame that includes the differences, the lower bound of a confidence interval, and the upper bound of the confidence interval for all of the group comparisons. So there's none some, none much, and some much are those comparisons. So that's how I was able to get this particular table. Now it's time for the summary of conclusions. Teacher training is associated with the response to misbehaviors in the classroom, p less than 0.01. Actually, I probably should have said, let me change that to say, to be consistent with what I did up here when I said 001. So let me put in 001. There we go. Okay, and up here I'm going to put in a 0 before the decimal point as well. I always like that. And then let's re-knit, and that change should be made. In the sample for this study, a higher proportion of teachers with no training, about 30 percentage points higher, were punitive than the proportion of teachers with at least some training. A higher proportion of teachers with much training were more reasoned by about 30 percentage points. And by the way, if you're thinking, why didn't he say 27 percentage points? I'm thinking in terms of conveying the message. And really, if I took another sample, that's going to vary. I'm going to get something different. I might get 32 instead of 27 the next time. So thinking about what I'm trying to convey and the fact that there's variability in my estimates, I'm just rounding this up and rounding it down to the nearest 10. So that's why I'm doing that. A higher proportion of teachers with much training were more reasoned by about 30 percentage points than the proportion of those with no training, and by about 20 percentage points than the proportion of those with some training. We already talked about that and saw that. A lower proportion of teachers with no training and with much training were evasive than those with some training by about 10 percentage points. So these data lead to 95% confidence in inferences to the population that a higher proportion of teachers with no training are punitive than the proportion of those with at least some training. Now, why am I saying that? Because if you look at the bounds of the interval comparing no and some, the bounds are 0.16 to 0.52. So you might say, well, that's only 2 percentage points, but it could be as high as 0.52. And if you're worried about that being close and don't want to make that statement, I understand. But I certainly, when I come over here to none much, the lower bound is 0.098, so about 0.1, so about 10 percentage points. That's the lower bound. And then when I compare to the upper bound, that's all the way up to about 60 percentage points. So that's why I'm saying that those inferences can be made. And also that a higher proportion of teachers with much training are more reasoned than teachers with no training. So again, none to much on the reasoned. If I look at the lower bound, it's in favor of reason by 59 percentage points on the lower bound. And the upper bound here, it's in favor of reason by 5 percentage points. Now again, those are minuses, and that's why the upper bound here is the 5. If I took the minus away and transferred it the other way around to talk about those in the much group first, then I would say the much group is between 5 percentage points and about 60 percentage points higher. Notice those are the only ones I talk about with 95% confidence, because there are a lot of these intervals here, such as all of these right here, in which you not only do you include 0, but they're very wide on either end of 0 there. So I'm focusing for inferences. First I talk about description, which you should always do, and then I focus on inferences, on those that the inference actually tells me something meaningful. Here's my press release. Professor Michael Seaman, that's me, a researcher from the University of South Carolina, recently released a report of his analysis of data from a hypothetical study of the relationship of teacher training to their responses to misbehaviors. And here's a quote: "We are 95% certain that teacher training is associated with response to classroom misbehaviors." So basically, that's the omnibus result, right? That's the overall result. Seaman told the press conference about these results. "What we have discovered," he said, "is that training appears to lead to more reasoned responses to misbehaviors. Those with no training are least likely to use a reasoned response, instead are prone to punitive responses." That's what we saw up in the data. He went on to say that the percentage of teachers with training who were more reasoned was about 30 percentage points higher among study participants than those with no training, and the percentage differences were reversed when considering punitive behaviors, with about 30 percentage points higher number of teachers with no training exhibiting primarily punitive responses than those with training. Seaman cautioned the press that, quote, "These are all outcomes based on phony data." Remember up here at the very beginning, I said this is a hypothetical study. So in my press release, I'm saying you need to treat this as fake news. If these results were presented as the results of a scientific study, I could be banned from the scientific community. So that's my press release. So there's the report, putting it all together. You saw me actually do all these analysis in earlier videos, but I wanted to show you in the context of organizing it into a more formal report. I hope you found that helpful. And this will conclude this video series on analyzing categorical data, although we're going to continue to look at categorical response variables in the next video series, in which we just get our feet wet a little bit with logistic regression. So I'll see you there.